Evening everyone. We're back once again with another amazing science tutorial video. I'm Coach Spivey, joined with my son Jordan Spivey, and in this video tutorial we're going to be looking at machines and mechanical advantage. So let's get started. So what is a machine? A machine is a device that makes work easier by changing a force. Machines make work easier to do by doing one of three things. They can change the size of a force needed. So for example, a car jack jacks up a car by increasing the distance over which you apply a force, which decreases the amount of force you need to apply. So for example, here's our car jack right here, and this is the distance right here. The longer the distance, the less force I need to apply in order to jack up the car on this end. So I push down on this car jack right here, and then it applies a force on this end that lifts the vehicle up. And then secondly, changing the direction of a force, which we briefly talked about with the first example. And you push down on the car jack to make the car go up. So I push down on this end of the car jack, which makes the car go up on this end. And then third, changing the distance of which a force acts. Decreasing the distance through which you exert a force increases the amount of force required. So for example, if I was to try to push down on the car jack right in here, I decrease the distance, but I would need to apply a lot more force in order to lift the car at this point right here. But if I increase the distance, the more distance that I've increased, then the less force I have to apply to make the car or make the vehicle go up. Let's take a look at friction in machines. And because of friction, which is the force that opposes motion, which causes heat, the work a machine does is always less than the work done on the machine. Machines that lose less heat are considered to be more efficient. So this makes sense because if a machine can lose less heat, that means it's not having as much friction, which makes that machine work that much better, that much faster, and makes it ultimately more efficient. Ball bearings are designed to cause less friction between moving parts in a machine, which will help it to be more efficient. So these are two examples of ball bearings. And what ball bearings do is allow parts of a machine to move past each other much more effectively and efficiently without the great loss of heat. So what is work input? Work input is the work done by the input force acting through the input distance. So if we take a look at the input force, that's the force you exert or apply on a machine. And then the input distance is the distance the input force acts through. So for example, if you're pulling on a pulley, here's that input force. And your input distance would be how far did you pull this pulley down. And that will ultimately determine your output force on this right hand side. Now let's take a look at work output. And that's going to be the output force of a machine multiplied by the output distance of the machine. And our output force is going to be the force that is exerted by a machine. And the output distance is going to be the distance the output force is exerted through. So let's take an overall look at work input and work output. So our work input is the work being done on a machine. So in this example right here, the machine is going to be this screwdriver. And the work input is going to be the work being done on the machine or the screwdriver by this young man. So he's pressing down on the screwdriver and applying a certain amount of input force. And that's our work input on the machine. The work output would be the work being done by a machine. So the work being done by this screwdriver to prop the top or lift the top of this lid off of this paint can. Now let's take a look at mechanical advantage. And that's going to be the number of times a machine multiplies your input force. So how much easier it makes your work. So for example, if you push on a car jack with a force of 25 pounds and the jack lifts a 2,500 pound car, what is the jack's actual mechanical advantage? Well, in order to solve for mechanical advantage, you would take your output force and divide it by your input force. So let's also look at our triangle over here. So we're solving for mechanical advantage, and we will take our output force and divide it by our input force. So let's go ahead and set that up. So I have mechanical advantage right here, and we have our output force right here divided by our input force. And if we take a look, our output force is actually being able to lift this 2,500 pound car. So the output force would be that 2,500 pounds. So the 2,500 pound car. The amount of input force we use to move that jack is going to be 25 pounds. So our output force is 2,500 pounds divided by our input force, which is 25 pounds, and the mechanical advantage of this jack is going to be 100. So now let's move on to our ideal mechanical advantage. And that's going to be the mechanical advantage in the absence of friction. And we call this ideal mechanical advantage because this would be our mechanical advantage if there was no friction. But we all know with any mechanical advantage, there's always going to be friction or heat created. So the actual mechanical advantage will always be less than the ideal mechanical advantage because of friction, which opposes motion and causes heat, which causes heat loss. And because of this, engineers are challenged to design and build machines with low friction materials. So for example, ball bearings and lubricants. And if they can design materials or design machines that have less heat loss or less friction, then machines are actually able to be more efficient and actually last much longer. So to solve for ideal mechanical advantage, our formula would be input distance divided by our output distance. So let's look at a practice problem. So here we are, we have Jack who drives his car 2.2 meters along a ramp to raise the car 0.5 meters for an oil change. What is the ideal mechanical advantage of the wheel ramps? So let's go ahead and use our formula again. So our ideal mechanical advantage is going to be our input distance divided by our output distance. And so the input distance would be that 2.2 meters that Jack drove his car along that ramp. So it's going to be those 2.2 meters for the input distance. And then for the output distance, that's going to be the height that the ramp raised the car, which is going to be 0.5 meters. And when we take our input distance and divide it by our output distance, which is 2.2 meters divided by 0.5 meters, that's going to give us an ideal mechanical advantage of 4.4. So what exactly is efficiency? And efficiency is going to be the percentage of work input that becomes work output, and that's going to determine the efficiency of a machine. And the efficiency of any machine will always be less than 100% because there will always be some friction. And if we can reduce the amount of friction, we can increase the efficiency of a machine. So here's our formula for efficiency right here. And we will take our work output and divide it by our work input and then multiply that by 100%. So another way we can look at it is by looking at our efficiency triangle formula. So here's our device efficiency right here, and we want to solve for that. So we will take our useful energy output, which is the same as our work output, and then divide it by our total energy input, which is the same as our work input. Once we get our number, we will take that number and multiply by 100 to get our percentage of efficiency. So say if we want to solve for our useful power output. So in order to solve for our useful power output, we will take our device efficiency and then multiply it by our total power in. So basically we will be taking our device efficiency and multiply it by our work input. And then say if we want to solve for our total power in or our work input. Then we would take our useful power output or take our work output and then divide it by our device efficiency, and that would give us our total work in. So now it's time for your check for understanding. And you're going to answer the following questions based upon your knowledge of machines, mechanical advantage, and efficiency. And I even put the efficiency triangle formula down here at the bottom for you to use as a guide as well. Ladies and gentlemen, go ahead and pause the video, answer the following questions, and this should help you to be able to understand machines, mechanical, and efficiency that much better. Ladies and gentlemen, I'm Coach Spivey, signing off with my son Jordan Spivey, and y'all have a wonderful, awesome, peaceful, positive day. Thanks everyone. Peace.